Hey guys, in this average to savage session, we'll be dealing with some of the physics problems that came this year in JEE Advanced, and at the end of this video, you'll be able to deal with them pretty easily. And at the same time, I've given a PDF of all the questions that I've discussed in the description down below. Do read the PDF and try solving it yourself before you watch this video. All the best. Okay, so let's get started with the first question. The first question says that there are two heat baths, and this one is at 300 Kelvin, this one is at 100 Kelvin, and there are two conductors of conductivity K1 and K2, and the temperature at the junction is given. What we need to find is the ratio between K1 and K2. So we will simply apply the heat current formula. As you might know, heat current is the temperature difference divided by the resistance. Like you might have remembered that in current electricity we have V equals to IR. Similarly, in heat we have delta T equals to heat current into resistance, where delta H is the heat current and delta T is the temperature difference. So we'll apply it on this case. So it's going to be 300 minus 200 divided by the resistance. We've been given conductivity, and we know that resistance is resistivity L by A, and resistivity is equal to the inverse of conductivity, so resistance is 1 by K1 L by A. So this is 1 by K1 L by A. The heat current will be same because K1 and K2 are in series, and we'll write the heat current in this case, which will be 200 minus 100 divided by 1 by K2 L by A, where L is the length of the conductor and A is the area of cross section. We've been given that the length is same, so we'll be cutting it off. And area, now this one has a radius that's twice than that of K1, so we'll write 100 divided by 1 by K1. Area will be pi r square, and this will be 100 divided by 1 by K2. In this case, since the radius is twice, we'll be writing pi 2r square. Right, 100 gets cancelled off, and we are left with K1 pi r square equals to K2 into 4 into pi into r square. We need to find K1 by K2, which will be 4. So this was the answer. Alright, so in the next question, the question says that there's a 1 kg block that moves with a velocity of 2 meters per second. It elastically collides with a 2 kg block which is connected to a spring of spring constant 2 Newton per meter, and after collision we need to find by how much distance did the 1 kg block move when the spring returned back to the 2 kg position. So what I mean is, when the 1 kg block collides with it, the 2 kg block will move inside, while the 1 kg block presumably will move to the other side. So when the 1 kg block moves to this side and the 2 kg moves this side, and what's going to happen is the spring will get compressed, and it will get compressed to a maximum extent, and then it will return back to this position. And when at the time when it returns back to this position, we need to find by how much distance did the 1 kg block move from its initial position, that is this. So what we're going to do is, let's collide the blocks together. I'll assume that this one attains velocity v1 after collision, and this one attains the velocity v2 after the collision. So conserving linear momentum, we'll be writing 1 into 2 equals 2 into v1 minus 1 into v2. The reason I took it as negative is because it's in the negative direction. Now since it's an elastic collision, we'll be using the coefficient of restitution formula, which says that E equals to velocity of separation divided by velocity of approach. So E is 1 in case of elastic collision. So 1 equals velocity of separation is v1 plus v2, because both are in opposite directions, so we add them up, and when they are in the same direction we subtract them. And remember that E is always a positive quantity, so we subtract the higher one from the lower one. And the velocity of approach is 2, since this one is in rest and this one is approaching with a velocity of 2. So v1 plus v2 is 2. I'll add both these equations so that v1 gets cancelled out, and we'll be left with 3v1 equals to 4, which gives me v1 equals to 4 by 3. And that should give me v2 equals 2 minus 4 by 3, which is 2 by 3. So v2 is the velocity of this one. Now let's imagine the situation. This gets compressed. Okay, I'll draw it. The spring gets compressed and then comes back to this position. Now remember that the time period of oscillation of spring block system is 2 pi root m by k. Now this is the total time period when the block goes like this, comes back, and again goes to its initial position. But in this case what's happening is it's going back and coming back, so it's going and coming, so it's just half of the time period. So we'll be dividing it by 2, which should give us pi root m by k. So the time that it takes to come back to its initial position is root pi root m, which is 2, and k, which is 2, so it's pi seconds. What we need to calculate is how much did this block move in pi seconds. So the entire sum has been reduced to a situation in which we've got the velocity, we've got the time, we need to find the distance. So d is 2 by 3 into pi. In the question it was given that we should assume pi is 22 by 7, so this should give you the answer. That's it. Let's move on to the next question. In this question we've been given the potential energy and the mass and the fixed distance r, and we've been said that this body moves in a circular orbit, and the question asks us to find the velocity and angular momentum. So let's do it. We know that force is minus du by dx, where du is the potential energy and dx is the distance. So F equals minus 2kr by 2, which gives the magnitude of force to be kr. Now since this is moving in a circular path, the force will be equal to the centripetal force, which will be mv square by r. This is equal to kr, and that should give us velocity to be equal to kr square by m and its whole root. The second part of the question asks us to find the angular momentum. The angular momentum is given by r cross p, and since r is perpendicular to p, this is the velocity, we can say its magnitude is rp sine theta, and theta is 90, so it will be just rp. P is mv, so this will be mvr. Mass has been given, and velocity is root kr square by m, and the radius is r. So these were the two answers. If yours matched, then congratulations. Now let's move on to a question on thermodynamics. We've been given a graph between temperature and volume, and the first question asks us to determine whether process 1 is isochoric or not. So isochoric means constant volume, and over here I can see that volume is varying as we go to the left, so I would say this is not isochoric. So option A does not match. Option B says process 2 absorbs heat. This is process 2, and what I can see is volume is increasing and temperature is constant. Now let's use the first law of thermodynamics, which says that delta Q equals delta U plus delta W. So delta Q is the heat, delta U is the change in internal energy, and delta W is the work done. Now change in internal energy is given by mu CV dt, where dt is the change in temperature. But as you can see, temperature is same, so dt will be 0 and therefore delta U will be 0. Now let's talk about the work done. Now since volume is increasing, as you can see, if you go by the arrow, volume is increasing, so work done is positive. So delta Q is positive, and positive delta Q implies that in the process heat has been absorbed, while negative delta Q implies that heat has been released. Let's move on to the third option, which says in process 4 gases release heat. Now similarly you can do the same. Delta Q equals to delta U plus delta W. Delta Q equals to delta U will be 0 since the temperature is constant, and delta W will be negative since volume is decreasing this time. And if we have a negative delta Q, it means heat is being released. So that makes option B and C correct. Let's move on to the third option, the fourth option, which says process 1 and process 3 are not isobaric. Now let's say PV equals to nRT. If it's isobaric, then volume is constant, which makes pressure constant, which makes volume directly proportional to temperature. And had this been the case, the graph of an isobaric process would have been like this. But as in this case, you can see the graph is like this. It implies that it is not isobaric. So these were the answers. So that makes B, C, and D the correct options. Alright, now let's move on to the next question, which is a question on dimensional analysis. The question asks us to find the relation between electric field and magnetic field. Now remember, whenever you get questions on dimensional analysis, try to derive formulas and put the dimensions. So eventually you'll lead into a relationship between E and B. For example, in this case, what I'll do is I'll write the formula of motional EMF, which says that the EMF is BVL. So this should give me EMF is magnetic field, where V is velocity, so it will be L t minus 1, and L is the length of the conductor, which is L, right? If you don't know this formula, then you can check out the description where you may get some theory related to this formula. And at the same time, I know that EMF is E into D, where E is electric field and D is the distance. So this will be E into L, the dimensional formula of distance. And I can equate both these to get a good relationship. E into L. I'll cancel out L. So this gives me E equals to BL t minus 1. And this also remember E equals to BC, where C is the speed of light. It was a pretty easy question too. Alright, now let's move on to an easier one. And this one asks for a relationship between epsilon naught and mu naught. Now, if you've been studying in 12th grade, then presumably you should know that epsilon naught into mu naught equals 1 by c square. If you want to know the proof of this, then you can check out in the description. I have given a link to the proof of how this has been derived. And since we need to find the dimensional formula, I'll be writing mu naught into epsilon naught is 1 by, this is speed of light, so it will be L t minus 1 the whole square. This should give me L minus 2 t T square, mu naught into epsilon naught. So mu naught equals epsilon naught minus 1 L minus 2 T square. It was pretty easy.
Alright, so I hope you enjoyed the session. Now, in case you have got a comment, a recommendation, or a doubt, you can email me or leave a comment down below so that I can read it and come back to you as soon as possible. Thank you and keep watching.